Hi there everyone, in this last video on the normal distribution series we're going to be looking at some problems. I think I did one really similar to this at the end of the last video that involves finding the mean or the variance or both given a certain amount of information here. So if we look at this first example here, we've got a random variable x, normally distributed, mean mu, variance 20. I'm telling you that the probability x is less than 30 is 0.843 and we want to find the mean. So it's again really handy to draw a diagram. When you get this question, draw a diagram like this because then it's really clear in your head. Put the 30 where it's meant to be, the mean where it's meant to be, shade the area, indicate the area, and I think the problems will be a lot easier if you draw the diagram. Okay, so in this problem here we want to find the mean. We're given the variance here as well. So the key formula in all of these things is this formula here. This is the formula that transforms x values to z values, and remember our z values are just the number of standard deviations away from the mean that a particular score is. In this case the score we're talking about is 30. So let's look at this formula now and look at the parts that we've got and we haven't got for this situation. So we've got a x value of 30. We don't know the mean. We know the standard deviation. We're told in this question here that the variance is 20, so therefore the standard deviation is the square root of 20. Do we know the z value? Yes, we can work that out. We can work out for this particular situation what's the z value so that all of the area from this point down is 0.843. So we can get our calculator to work that out. Now you don't want to go through the horrible table thing, that's awful. You can use your calculator using the standard normal distribution and you should get 1.007 for the z value there. So that's 1.007. In other words, that's just above one standard deviation from the mean, that score of 30. So you can clearly see we can then solve that equation to find the mean. Here's the working. So I'd multiply both sides by the square root of 20, going from there to there. I'd then add the mean to both sides and subtract this thing here, and that should give you 25.5. And you can always look across and see if that looks reasonable. It looks reasonable that 25.5 could be the mean there. So there's an example of giving you the probability, giving you an x value, asking you to find the mean. In this example here we've got the heights of year 12 students, mean mu, so we don't know the mean, and standard deviation 1/15 of the mean. So this is a different way of giving the standard deviation. We know that the probability somebody is over 182 centimeters tall is 0.04. So the way that could be said is 4% of people are over 172 centimeters tall. So we want to find the value of the mean. Okay, so write this step down. This is a really good one to write. X is normal, mean mu, standard deviation 1/15 mu. So we first need that z value. If I draw the diagram here, I know that this area up here is 0.04, 4% of the whole graph. Then you know that's 182 and above, so I can look up that z value. That is on my calculator, and I'm going to do the inverse normal. We're looking for the tail to the right, probability of 0.04. We've got the mean, or sorry, in this case we don't need the mean standard deviation, we're going the inverse normal, and we're using a standard deviation of 1 and a mean of 0, so the standard normal, and that will spit out our z value. Clearly it's positive, it's above the mean, so it's positive. If we do that, we should get a z value of 1.751. Try that to just make sure you've got it. And then we substitute in this formula again. We've got the z value, we've got the x value 182, we don't know the mean. In this case we don't know the standard deviation, but we do know it's 1/15 of the mean. So this is the equation that we get here. So multiply both sides by 1/15 mu, gives us this step here. I'm then going to add the mean to both sides. So 1.751 times 1/15 gives us this value here. Then add the mean to both sides, so we get one lot of the mean plus 0.11673 lots of the mean, giving us 1.11673 lots of the mean. Divide by that number, gives us 163 centimeters for the mean. Look at our diagram, looks reasonable to me. Second part of the question says 5 students are selected at random. Find the probability that more than one student is over 180 centimeters tall. Okay, so more than 180 centimeters tall. This is a standard problem where we now know the mean, We know the standard deviation is 1/15 of the mean, so therefore we know the standard deviation is 10.9, and we just want to know what's the chance that we're more than 180. So that is really easy to put all those values in and get it out on your calculator. So don't worry about the working here. This is the kind of thing you'd have to do if you didn't have a calculator. The answer is 0.0586. So recognizing now that this problem is switching to a binomial question. We've got 5 students. Each one of them is either over 180 or not over 180, so there's only 2 options. Each person is independent. All of those things means this is a binomial distribution, so you've got to write this in your answer. Binomial with n equals 5 and p equals 0.0586. So we use the normal distribution to find the probability of a success here, or someone being over 180 centimeters tall. Okay, and then it's just a matter of using the binomial formula. We want the chance that there was more than one person in this group of 5, so you could just use your calculator to work that out. I've got here on the screen how you do it using the formulas. So the chance that you're bigger than 1 means 2, 3, 4, 5, so you'd need to use the formula 4 times, or just 1 minus the probability that there's 0 or 1 person over 180. So there's the formula there, and the answer is 0.0305. Again, check this on your calculator using the binomial distribution with these parameters here to make sure that you can get the right answer. Alright, this is the last question now. In this question here, we're not given the mean or the standard deviation, but we're given 2 bits of information. So we've got the speed of drivers on a motorway. We know that 24% of the vehicles that we clocked were going faster than 100 kilometers an hour. So let me put 100 kilometers in here. And we know that 4% of the vehicles were doing less than 90 kilometers an hour. And from that information there, we're going to find what the mean and standard deviation is of the speed of the vehicles on the motorway or on the freeway. Okay, so we need the z values associated with those 2 areas. So again, I can use my calculator, say it's the right tail, the probability is 0.24, mean of 0, standard deviation of 1. That will give me the z-score associated with this area here. Similarly, this one at the bottom, the tail on the left, 0.04, mean 0, standard deviation 1, that will give you the z-value associated with this score here. So if you do that, you should get 0.707 for the top one, negative 1.751 for the lower one. Okay, once we've got those 2 scores, we can then put them into the formulas. So in the first case, 0.707, we know the x value was 100, we don't know the mean, we don't know the standard deviation. In the second case, we know the z value, we know the x value, we don't know the mean, we don't know the standard deviation. From those 2 equations, we then solve simultaneously. So I've done that by multiplying both sides here by sigma, the standard deviation, giving me these 2 formulas, and then I've subtracted the equations, which then gets rid of the mean. So this is what I've really done, that equation minus that equation. So you've got negative mu minus negative mu, so that ends up being 0. So those 2 means cancel out. You end up with this here, divide by 2.458, and remember using the exact value as much as possible. So there we've got the standard deviation of 4.07. I can then substitute that back into this formula here, and here it is here to find the mean of 97.1 kilometers per hour. If you go back to the diagram and check, 97.1 looks reasonable looking at that diagram that we've drawn.